Hello everyone, so we are starting on 6B. This is day 1 and this is interpreting relationships between quantities. So, learning goals for the lesson. I can create an equation and define variables given information in a real world problem, your favorite kind, and create an inequality to represent information given in a real world problem. Alright, so a couple of things to remember. 1, any constant, meaning the term that has no variable, will represent something that doesn't change. And any term that has a variable will be used to represent a value that is influenced by a quantity of some kind. So like number of minutes, number of items, etc. Alright, so let's take a look at the first example. Your watch is 5 minutes behind on Sunday. Okay, so that 5 minutes is probably going to be important, so we'll underline that. Each day, so when you see that word each or per, so let's see, each, per, means variable. Okay, each day it falls behind another 3 minutes. So 3 minutes, that's important. And since that was with this, that's going to be, we're going to write that as like 3m or 3x. We need to write an equation and define your variables, which would tell you how many seconds behind the watch is on any number of days. Alright, so what we're going to do is, I covered up our equation. This would be our equation. Y equals 3x, so like remember I said each day, so this is like number of days. Okay? And it was 3 minutes each day, so that's where this came in. And our variables, y is the number of seconds behind, total number of seconds, and x is the number of days. And then this part we added in, because remember your watch is 5 minutes behind already on Sunday. So constant, number of minutes behind already. So that's where we started with. Now, unlike the problem with the digging of the holes where we didn't include that, here we are because this is how many total minutes the watch is behind. And this is in minutes, this 3 is in minutes, and this right here, that's in minutes. I don't know why it's coming up like that, but that's in minutes as well. Okay? So all three match as far as what unit of measure they use. All right, example 2. So we go into a store with $150 to buy shoes and shirts. Shoes are $60, shirts are $20. We need to write an inequality. So this right here, inequality, that tells us it's going to be this, 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 or this. Okay? To represent the situation. And x needs to represent the number of shoes. So x, number of shoes, y, number of shirts. Okay? So our inequality. Okay. X is the number of shoes. How much did shoes cost? 60. Shirts are 20. And y was the number of shirts. So it's 60x plus 20y. Now, this is a possible total cost here. Okay? That right there. This is how much we have to spend. So this amount over here has to be less than or equal to the amount of money that we're able to spend. It cannot be more. Okay? So remember that. And that's all you have to do is just come up with this inequality. Simple as that. And there's the answer there. Sorry, this shouldn't have been up there. But let me see if I can... it doesn't matter now. Buying out of uniform passes for you and your friends, it costs $3 for each sticker. So again, see how that's 3 each. So that's the same as like 3 per. So anytime you see that, you know that has a variable. It tells you to use C for cost and P for the number of stickers. Now these aren't the same, so we're going to know that the cost is influenced by the number of stickers. We know that each sticker costs $3, and that's per the number of stickers that you buy. So that's how I came up with this, because this is number of stickers, cost per sticker would give you the total cost. And that's it. Nice and simple. Kept the video nice and short. If you have any questions, tomorrow would be a good time to ask. But if you ever have any questions, even if it's for something that's past, shoot me a message on Remind, ask me in class, whatever you need to do. All right? Thanks a lot, guys.